Okay, thank you very much. Thank you very much for your introduction. I'm Shinichi Nakano from Kyoto University Center for Research. So today, I'd like to introduce my former project of the microcystis. For microcystis, Hans has already introduced that very toxic and dangerous microorganisms. So I skipped the what microcystis is. Okay, so my project consisted of the three universities. One is Kyoto University, another is Tsukuba University, final one is Fukui Prefecture University. And my project was consist of the three parts. The first part was lake research. We visited some lakes and collected the water sample and then made some analysis. And the second part was experimental research. It's ecophysiological molecular ecological work. And first, lake research was conducted by the Kyoto University and Tsukuba University, and the experimental part by the Kyoto University and the Fukui Prefecture University. And the final part was environmental sociology research. This project was sponsored by the Minister of Environment in Japan, and the Minister of Environment asked me to include some environmental sociology to think about the relationship between the microcystis and the human activities. So that's why the Kyoto University, my team, they hired one postdoc about the environmental sociology. And our final goal was to reduce the risk of the microcystis as much as possible. But we conducted the main items of the microcystis research. So today I'd like to introduce you some of them. The yellow part, today I'd like to talk about. So first topic is the dispersal of microcystis by birds and human activities. But today I'd like to focusing on the bird transportation of microcystis. As you know, not only the human activities, but also the bird transportation can transport the microcystis all over the world. For example, the human activities, we want to have some water resources from everywhere, and so we develop some canals or some other the artificial rivers or streams. Something like the creeks introduced by the ants, but the purpose was different. But migratory birds also can transport the microcystis from lake to lake. So, for example, the mallard duck can migrate whole the earth like this. This information was obtained from the internet. One of the postdocs, she was a bird ecologist. She examined mallard duck migration like this, and so we kept the duck in our lab, and we forced the mallard duck to drink microcystis culture. It is very hard for the mallard duck, but we did that, and then we checked their feces, fecal pellets, whether the fecal pellets they had the microcystis cells. And then we collected the fecal pellets of mallard duck and observed the fecal pellets under the microscope. And sometimes we could observe the microcystis cell like this. And also we checked under the epifluorescence microscope to confirm, to examine whether the microcystis cells was alive or not. And sometimes we could find alive microcystis cells. And we also checked the microcystis gene using some molecular techniques and to find some microcystis genes within fecal pellets. This is one of the results. The horizontal axis means the retention time in the mallard duck's gut, and from the 0 to the some hours. And the vertical axis shows the percentage of living microcystis cells in the fecal pellets of mallard duck. As we can see here, after the 0 time is we force to the mallard duck to drink the microcystis cultures here, and after 4 hours, still about 10% of the microcystis cells still alive in the mallard duck fecal pellets. And that was also the case in the after 10 or something. So the average flying speed of the Malad duck is about 70 kilometers per hour. So 4 hours means that the Malad duck can fly about 300 kilos. 300 kilos is very long. So the Malad duck who ingested the microcystis cells can transport microcystis from the Kyushu island in Japan to the Korea, or from Korea to the Kyushu island. It's possible. So the 4 hours is long for us to prevent from the microcystis transportation. So second, the topic is phylogenetic distribution of microcystis in Asian countries. So due to the transportation of microcystis through the human activities or the marine birds, so we have some geological distribution of the microcystis species and the genotypes. And this is a result by the scuba team, and they collected the microcystis samples from the many Asian countries, also in some lakes from Japan, and they examined the genotype of the microcystis. We focusing only on microcystis erinosa, but microcystis erinosa consists of the many genotypes. And they use the MLST method, but I skip how the method is. And as we can see, the scuba team could categorize them from A to something, the genotype of microcystis. And they expected, they thought that their hypothesis was that there would be some special microcystis genotype which distribute only in the, for example, Laos, only in the Myanmar or something like that. But that was not the case. So every microcystis genotype distributed so many countries and also in Japan. So the microcystis has already been transported to everywhere through the human activities and the birds. So that we have every seeds of the microcystis genotypes all over the world. And then the Tsukuba team also examined the many lakes in Japan, the same method, and they find the very exceptional case. In 2009 or 2010, G-type of the microcystis distributed only in the Kanto area of Japan. So this was exceptional. So sometimes we have the limited microcystis erinosa genotype distributed in a very limited area. This was also the case for the Lake Shinji. This is the brackish water. In the brackish water, we have a very special microcystis genotype. It's a SJ type. This microcystis has a tolerance for the brackish environment. And the Kyoto University team also collected the water sample from the Kansai and the Shikoku Kyushu area reservoir ponds to examine the microcystis genotype. But again, we cannot find any tendency for the geological distribution. So as a conclusion, we have already the wide distribution of the various genotype of the microcystis, not only in Japan, but also in the Asia and maybe all over the world. So let's move on to let me talk about the next item, the growth of the microcystis with special reference to the nutrient supplies. In Hans' talk, Hans emphasized that not only phosphorus but also nitrogen is very important for the microcystis dominance. And to reduce the microcystis bloom, we have to reduce not only phosphorus but also the nitrogen very much. And to examine the nutrient supply effect on the microcystis growth, we artificially brought the microcystis bloom in the artificial pond in my institution. So we put the nutrients over and over again every 1 week or something. And finally, we get the artificial microcystis rooms like this in the outside artificial pond. And then we changed the supply of the nitrogen and phosphorus ratio to each pond. And when we put the nitrogen and phosphorus in a very low solely low, yes, NP ratio here. So we could not massive growth of the microcystis like this. But when we applied the supply to the high NP ratio of nutrients to some of the ponds, we had the massive growth of the microcystis like this. So the Hans was very correct because the nitrogen is very important for the microcystis growth in the actual outside the pond. And this experimental research was conducted by Fukui Prefecture University, Professor Kondo, and they purchased some microcystis strains from the NIST, the National Institution of Environmental Sciences. And they examined the growth of the microcystis under the various nitrogen concentration like this. And the blue line shows the microcystis bilitis. The other strains were microcystis aeruginosa. As we can see here, the blue line lower than the red line. This means that microcystis bilitis was less competitive for the nitrogen compared with the microcystis aeruginosa. Maybe some of you not know that the microcystis bilitis is maybe highly toxic than the microcystis aeruginosa. And then we also examine the various phosphorus availability for the growth rate of those microcystis strains. And finally, we can find that those two are same results. But I enlarged this one for this low concentration part like this. So as we can see here, under high concentration of phosphorus, the blue line lower than the red line. This means, again, the microcystis bilitis, highly toxic one, is less competitive with the aeruginosa. This is also the case for the low concentration of the phosphorus. So the blue line lower than the red line. This means the bilitis is a weaker competitor to the aeruginosa for the phosphorus. So we concluded that the microcystis bilitis is less competitive than other microcystis species. This means the aeruginosa in terms of response to nutrient supply. Okay, let me move to the another topic. We conducted for the better management of microcystis blooms. We conducted the 3 items of the microcystis, and so today I'd like to talk about early detection of microcystis blooms. This is related to the microcystis blooming forecast. And I myself is a protozoan ecologist. I'm very much interested in the grades of microcystis, and we have got the results that some protozoan species could graze on the microcystis about 25%, only 1 per day. But today I skipped that result, and I would like to talk about early detection of the microcystis. This is a simplified figure of the photosynthesis of the phytoplankton. When the phytoplankton receives the light, this is something like a cyanobacterial system, and the electron would transport from the PS2, the photosystem 2 to photosystem 1 like this. And some part of the energy would be released as a fluorescence. But when we apply the DCMU, it's a photosynthesis inhibitor, the transposition of electron here would be blocked, and all the energy released as a fluorescence. We used this system, and if we use the 590 nanometer light, which is this light of the wavelength of light is absorbed by the cyanobacterial phycocyanin, cyanobacterial pigment. And if we use this wavelength light, then we can measure the fluorescence intensity of cyanobacteria. So this is fluorescence can be used for the potential of photosynthetic activity. So that if this fluorescence is very weak, the photosynthetic activity of phytoplankton is also weak. If this fluorescence is very strong, the photosynthetic activity of the phytoplankton is very strong or high. So if we use this light, we can measure the cyanobacterial photosynthetic potential. So we applied this method to the outside microcystis bloom in at our institution, and we can find this result. And as we can see here, this is the time, and we have a microcystis bloom here, followed by the alpha-nizomenon isachericoid bloom here. And please take a look at the green diamond, and we can hear when we have the microcystis bloom here, it's not so easy, but we have an increase in the diamonds. And when we have the decrease of the microcystis, we have a decrease of the diamond. And then we have the alpha-nizomenon bloom, we have again the diamond increase. So that we thought that we would apply this method to have the early warning of the microcystis bloom in the eutrophic lake or reservoirs. Now, this work was already published in the Journal of Plankton Research, and now the Japanese Ministry of the Land and Traffic people are interested in this method, and they have been conducting many experiments to make feasible this method to have the early warning of the microcystis bloom in the dam reservoir, because many dam reservoirs in Japan is managed by the Ministry of Land and Traffic. So this is the brief explanation of what we add, the new information for the microcystis research within our project. And I would like to skip this one. And yeah, using this slide, I'd like to emphasize the sharing the information is very important to avoid the risk of the microcystis. The Australian case is maybe the best. The information about the microcystis blooming is shared by not only the researchers and the administration, but also for the ordinary people. This is a very good system. But in Japan, maybe in Korea, still not so enough. The information about microcystis shared only by the government and the researchers. And ordinary people do not so familiar with the microcystis. And Vietnam, Kenya, unfortunately, not so enough, sorry. I have ever visited the Lake Victoria 3 times, but the Kenyan people did not have the enough information about the microcystis. So my midterm environment project has already over, but we have been conducting another microcystis research from the 2012 to 2015 together with the Chinese friends. And this study is mainly focusing on the solid matter loading. And but in Lake Typhoon, as you have already know that the Lake Typhoon has a microcystis group. So we have been researching on the dissolved organic matter production through the microcystis. And one of my collaborator, Dr. Harker, is here, and we have another 2 more Chinese friends. And then we have been trying to get another grant from the JSD to conduct more research about the cyanobacteria in Japan and China like this. But this is still under review. I'm not sure whether we get success or not. Thank you very much for your kind attention. Sorry, my very quick talking because time is limited. Thank you very much.